Hello and welcome to our 13th session where we are going to now discuss about the exposure setting. This is day 3, hour 3. So in this session, we are now going to start with what actually is this exposure settings. To understand this, on the screen I have projected you with an image which has pure white at one end, pure black at one end, and in between you have 4 gradations. I want to record this as it is on my camera. See, when you are seeing an image, there is nothing more whiter than white. Say, for example, this white area, whether you see it in 100 watt light, 500 watt light, or 1000 watt light, this white area remains white. Similarly, even in a camera sensor or film, there will be a particular intensity. And if you give this particular intensity of light, white area will be recorded as pure white. The camera, this intensity range, we call it as the dynamic range, where white should have the maximum value and black should have 0 value. 0 to maximum, the value has to be between black and white. So this value, it depends upon your film sensitivity. Say, for example, I have a 100 ASA film. I will come to what is this ASA or ISO later. Say you have this 100 ISO film, and in that, I need 100 watts light to turn white into white, 0 watts light to turn black into black. When you give exact 100 watt light, this area will get 80 watts light and it will be light gray. This will get 60 watts. It will be slightly darker. This will get 40 watts. This will get 20 watts and it will be dark gray. And in black area, there will be 0 watts light. So to record it correctly, I have to give exact 100 watt light to my camera sensor or the film. You cannot always shoot any object only in 100 watts. Now what happens is when we are doing the shooting, the lighting varies over a very large range. To give you an example, when you are shooting picture in a hot sun, the light falling on this image will be 8000 watts light. And if I give this 8000 watts light full as it is to my film screen, what happens is all the areas here will turn white because of that intensity. Okay, so you will be seeing a white screen. It will be completely overexposed. So now what I have to do, when I have 8000 watts in a hot sun, I have to cut it down and bring it down to 100 watts. How can I cut this intensity? The control that we are going to use is called as aperture. See, what this aperture does is, it is going to reduce the diameter through which the light passes in your lens. Now, when this diameter is fully open, it is equal to your lens power. Now, you have 8000 watts. So now what we are going to do is, if I set this aperture to number 2, what happens is 8000 watts light will be cut down exactly half to 4000 watts. We call this as f stops. Now, in any camera, if you see this aperture number, it will be the same. Only the first number is going to change. Either it will be 1.4, 1.2 like this. The first number is determined by the lens power. Then the subsequent number will be 2, 2.8, 4, 5.6, 8, 11, 16, 22, 32. It is in a particular order. And why they have each number, we call it as a f-stop. 2 to 2.8, if you change, it is called as 1 f-stop. And for every 1 f-stop, the calculation is done in such a way so that the light cut down exactly by 50%. So now, if you have 8000 watts light and if I change it to 2, light becomes 4000. If I change it to 2.8, light becomes 2000 watts. If I change it to 4, light becomes 1000 watts. If I make it 5.6, light becomes 500 watts. If I make the aperture 8, light becomes 250 watts. And when I set the aperture to 11, 125 watts is going to reach the film. And now, if I keep the aperture stop something between 11 and 16, I will be giving exact 100 watt light to the film. So when you are having a bright sunlight, I will keep the f-stop to 11. And suddenly the weather becomes cloudy and the light reduces to 4000 watts light. then instead of keeping it 11, now if I keep 11, the intensity will fall down to 50 watts and it gets underexposed. Now what I will do is, I will open up the aperture to 8 or 5.6. So evening or early morning, when the sun is rising, when the light is very less, if there is just 2000 watts light, I will keep the aperture 4. So like this, irrespective of the light falling on the image, the light reaching the film, we are going to maintain it constantly at 100 watts light. And we are going to do this using aperture. More than 100 watts light, I can control it using the aperture. But say, for example, I want to take the picture in night. I am going to take a picture in the night under a street light, and the light is just 50 watts. I cannot make a 50 watt light 100 watt using aperture, because aperture can only cut down the light. It cannot increase the light. Now, how can I control this? So, when I control the exposure setting, now the second setting comes into the picture. This second setting, we call it as the shutter speed. Now, what is this shutter speed is? See, when you click a photograph, what happens is, in your camera, the shutter opens, leaves the image, exposes it to your film or the sensor, and then it closes down. And when it opens and closes, the duration for which the lens remains open is what we call as the shutter speed. Say, for example, you take a video camera, switch on the recording goes on continuously. And how this recording is done? Say, for example, in your regular mobile phone camera, which are all running at 30 frames per second, the thing is, every 1 second action of your video is recorded as 30 still pictures. To give you an example, say I keep my hand here and I am going to move it like this. Okay, this is a 1 second action. Now, this video, if I take it into Premiere or DaVinci Resolve, and if I zoom it, to 1 on frame, and if you watch it for 1 second, see, this 1 second video consists of 30 frames where the hand slightly moves in every frame. So, in a video camera, what happens is, when you start the recording, it takes one photo, closes, it takes the next photo, closes, like this. It takes 30 photos in 1 second automatically. In cinema, this frame rate is 24 frames per second. So even in cinema camera, one photo is exposed. When the shutter is closed, film moves 1 frame, again it exposes, then film moves 1 frame, again it is exposed. So like this, the frames are exposed. Your shutter speed of your camera is 30 frames per second, and your light needed is 100 watts, and now you are taking the picture in a street light, and if there is only 50 watts, if it is a still image, what you can do, instead of exposing the image for 1/30th of a second, if you expose it for 1/15th of a second, half of it, that 50 watt light itself becomes 100 watts. So, in case of lesser light, we are going to increase or compensate this light by exposing the film or the sensor for a longer duration. Say I have a candlelight light, and in candlelight, if I want to take the picture, there is just 10 watts light. And for this 10 watts light, what I am going to do, if I record it at 30 frames per second, I get only 10 watts light. If I make it 1/15th of a second, if I make the shutter speed, then this will become 20 watt. If I make it 1/8 of a second, this will become 40 watts. If I make it 1/4 of a second, this will become 80 watts. Here we are compensating it using our exposure time. Now, in case of still images, I can increase the exposure, but only thing is, when the camera lens is open, the subject should not move. Okay, if you are exposing it for 1/4 of a second, you have to ask the subject to sit and you have to take it. So if it is the case, in a still image, you can even shoot it at 1/4 of a second. But what about movie cameras? In your 30 frames per second camera, you cannot reduce it below 1/30th of a second. I cannot record 15 frames per second. So if I am going to expose every frame for 1/15th of a second, I will get only 15 frames and the film becomes jerky. I cannot change that frame number. So now I cannot increase the exposure. I want to shoot it in street light. The light is just 50 watts. I cannot increase the aperture. I cannot change the shutter speed and bring it below 30. Now, how can I shoot it? There is the third control which we use it for this purpose, which is nothing but film sensitivity. In olden days, when films were manufactured, we were measuring it with an international standard. Previously, it was called as ASA. ASA stands for American Standard Association. Then it was also called as DIN. DIN stands for Dutch International Norma. And we also had a standard called as now ISO. ISO means International Standard Organization. And today, all these controls are used in ISO. Say, for example, if your camera has a sensitivity of 100 ISO, it is 21 DIN, then it requires 100 watts light to record the image or the white area correctly. It is the minimum light required. However, if the light is 50 watts, then what I can do is, instead of using a 100 ISO film, if I use a 200 ISO film, which is more sensitive, in case of a 200 ISO film, to record white area as white, it doesn't need 100 watts light, it needs only 50 watts light. So, instead of changing aperture and shutter speed, if I use a 200 ISO film, now, even in the street light, I can expose the image clearly. So, this third control, we call it as film sensitivity. In olden days, when we were making the films, before shooting itself, I have to decide whether I am going to shoot it in 100 ISO, 200 ISO or 400 ISO. So if we are shooting in night time, we used to load a 400 ISO film, and daytime we used to use a 100 ISO film. So the entire film, till it is finished, I cannot change the ISO. But today in digital, you can manipulate it. You can take every photograph with different ISO. So this ISO in digital cameras, what it does is, it actually amplifies your signal. So now, whatever signal is coming from your sensor at 100 ISO, if you change it to 200 ISO, that signal will be amplified by 200%. So there will be an amplifier and it is going to amplify the signal. As this sensitivity increases, you need lesser light to record white area as white. Say, for example, if I use a 400 ASA film, just 25 watts light is enough to record a white area as white. If I use a 800 watt ASA film, I need just around 12 watts. So the thing is, the greater the film sensitivity, I can shoot it in lesser light. However, this comes at a catch. As the ISO increases, even in old film, what used to happen is, because of the dyes, we started to get a thing like grains, especially in gray areas or mid-tone areas. Say, for example, in areas below my neck, below my eyebrow, in these areas, those gray area used to appear as grains. And we call this in digital world as noise. Actually, in digital cameras, if you increase the ISO, what happens is, if you amplify this signal from 100 ASI to 800 ASI, if you amplify it 8 times, the picture actually what happens is generates noise. And so, when you are seeing this image, the picture will be very noisy, as I am showing you here. In case of latest cameras, what they are going to do is, using the latest AI technology, they are going to recalculate these image pixels and they are going to regenerate it and they are going to replace it with the noisy image. And because of that, today most of the camera says that you can shoot it in low light condition. In an iPhone 16 Pro, even if you shoot under a street light, the picture will be very good. It is called as night photography. And for night photography, today you won't get any grains because it is actually manipulated using a software. So now we have 3 controls here. What you have to adjust is, we call this as exposure triangle. See, one is aperture, another is shutter speed, and third is the ISO. So now, say for example, in a bright sunlight when you are taking the picture, ISO is 100, your shutter speed is 30 because I cannot change it in a movie camera, and your aperture is, say for example, 16. Now, in that bright sunlight, I need very less depth of field. So, I want to shoot the same picture with aperture 2 to reduce the depth of field. I have told in the previous class, to reduce the depth of field, I have to keep aperture maximum. So, if I keep aperture 2 in bright sunlight, what happens? The entire picture gets overexposed. So, here I have to change the ISO from 100 to 50. I have to make it low sensitive. And similarly, if I change it from 11 to 8, I have to make this 25. Now, I cannot take it below 25. Normally, getting it below 100 ASA, it's difficult. So, in these cases, we use a kind of filter called as diffusion filters. So, these filters, what they do is, they are going to diffuse the light. So, in bright sunlight, if you want to shoot with aperture 2 or 2.8, in front of our lens, we use this diffusion lens and we are going to take the picture. So, we have just now understood this exposure triangle. We call this as aperture, shutter speed, and the third is the film sensitivity measured in ISO. So, we are going to control the light reaching the film and we are going to maintain it constant at the required rate irrespective of the shooting condition using these three controls. Now, after understanding it, before we jump into Unreal Engine, I just want to say one more thing. All this is regarding the intensity. Now, when you come into color, what is the definition of a color? See, actually, if you want a white area to appear pure white, you have to see it in white light. If you switch on a red light, if you see a white area, it doesn't appear white, it appears red. So, the color of your subject depends on the source light that you are going to use. In pure sunlight, you will have pure white light, that is fine. However, if the weather becomes cloudy, the weather is fully cloudy when there is no hot sun, what happens is, the light travels through the cloud, and when light travels through the cloud, blue is scattered more. According to Raman effect, this is the reason why we see the sky blue. So, because blue is scattered, now all white area in a cloudy weather starts appearing bluish. But in these cases, to compensate this, in camera, we do one more setting, we call it as the white balance. What is this white balance? Is we focus the camera to a white area with the source light that we are going to use, and we are going to adjust the color so that that white, if blue is more, we will reduce blue by increasing red and green. So, when we increase red and green, blue will be reduced. That is the magenta color, if I increase it, blue will be reduced and I am going to get white light. Okay, so this control, we call it as white balance. And actually this white balance control is done using a term called as color temperature. So what is this color temperature is? Natural light is fine, but artificial light, when you start using it, the very first artificial light humans invented was actually the Edison bulb. And the Edison bulb was using a tungsten filament lamp, and the tungsten filament lamp used to burn at a temperature of 3200 degree Kelvin, and the light we were getting from that was not pure white, it was yellow. So that's why the old electric bulbs that we use have an yellow tinted light. So, if I want to do a shooting in that, if I record the film as it is, every human in that appears like a jaundice patient. So now, in that light, I have to reduce yellow. So I will then add a cyan filter or a bluish green filter, and I am going to reduce the yellow. And this control, we call it as white balance. And here color temperature means you take any material. For example, you take an iron, you start heating it. The very first color that you get when something burns, do you know which is the color? It is red. So when something burns at a temperature of 1600 degree Kelvin, we get red color. If you heat it more at 3200 degree Kelvin, we get yellow color. And if you heat it to around 5000 degree Kelvin, we get pure white color. And if you continue heating, and if you take it beyond 6000 degree Kelvin, what happens is you get blue color. So we are going to compensate this using this color temperature setting. And the last thing that I want to discuss here is about the shutter speed. I already told you that all our regular cameras will have 30 frames per second, and cinema camera will have 24 frames per second. And in all our regular cameras, we used to use something called as a mechanical shutter. And what this mechanical shutter is, it is a mechanical part that is fitted behind your lens, which actually opens and closes 24 times per second in a cinema. And in our regular camera, it opens and closes at 30 frames per second. And these shutters are actually mechanical devices. Whereas in digital cameras, actually nowadays in digital camera, we use another type of shutters called as the electronic shutters. And in electronic shutter cameras, for example, all the mobile phone cameras uses this electronic shutter, wherein we are not going to use any shutter at all. The lens is continuously exposed to the sensor. By controlling the current flow 30 times per second or 24 times per second, we are going to control the image shutter speed. And these kind of shutters are called as electronic shutter. And actually, in this mechanical shutters, which are also called as rolling shutters, and in electronic shutter, since the information is taken pixel by pixel, sometimes what happens is if an object is moving very fast, say for example, you take the video of a jet engine, the jet engine wings are rotating. And when it is rotating, the shape of that wing is going to change, because when it is recording the image pixel by pixel, fast moving object gets distorted. And to avoid this kind of distortion, today all digital cameras comes with what we call as the global shutters. For example, Sony Alpha 9 and all these cameras are coming with global shutter, where the information from all the pixels are taken at a time. So in this case, you will not have any distortion when you are taking high-speed images. See, normally our eye, if you consider the shutter speed of a human eye, you can consider it as 1/32 of a second, because we see 32 frames of image every second. So every image is exposed 1/32 of a second. That's why if an object moves at a very fast speed, for example, a rotating fan wing, or when you are moving in a train, if you look down, you won't see the tracks. This is because when you are seeing something which is running more than 32 frames per second speed, our eye gets it blurred. And we call this as motion blur. The same motion blur, if you come into this video cameras, what happens is regularly you get this motion blur. But nowadays what is happening is we are entering into a field called as high-speed photography. High-speed photography means the recording of the image is not done just at 24 frames per second or 30 frames per second. Today, all the latest iPhone camera or Samsung cameras comes with 240 frames per second, 480 frames per second, and you have Samsung S24 and S25 recording at 980 frames per second. So what is this happening is, in these cameras, you can record 980 frames in 1 second. Means, say you have an action or a sequence where you are going to take an egg and you are going to break it. So when you are breaking the egg, say the egg may break in 1/4 of a second. But if I record it in 980 frames per second, our eye sees the image at 1/32 of a second. And if I play it back at 30 frames per second, now that 1/4 of a second action is going to play for about 4 to 6 seconds or 12 seconds. And now you can easily see how the egg is breaking, how the inside yolk is coming out. So these kind of actions we record it with high-speed photography. Say, for example, in fight sequences, when a hero is beaten, when they hit on his face, how his face gets distorted. Or when in an advertisement, when someone takes water and splashes on his face, every water drop will be clearly visible. For these kind of shots, we are going to make use of high-speed photography. So in camera, we are going to record it at a very high frame rate, and when we see it at our regular rate, it appears slow motion. So actually, when you want to make slow motion, we can do it in two types. One is take 30 frames per second image and drag it and extend it 60 frames or 120 frames digitally. And in this, there will be some amount of jerk. So without jerk, if you want to see it, then while recording itself, if you record it at 120 frames per second or 240 frames per second or 480 frames per second, the image will be much smoother. So that's why today, even in all mobile cameras and digital cameras, you have 60 frames per second. We use 60 frames per second so that the action is smoother. And when it comes to playback, and especially in Unreal Engine, we use this frame rate consistently. Because Unreal Engine is a game engine used to play games. And when you are playing a game, when you are taking a bike, you are riding a bike and the bike is running at 200 kilometers per second, means nothing will be clearly visible for you. Everything becomes black. And in that case, if you want everything to be very clear, you want that game to run at 240 frames per second or 480 frames per second. The greater the frame rate, the better will be the quality, and the image or the game will run very smooth. So that's why in all machines, you measure the performance of your machine using this frame rate. And this is also called as refresh speed in phones. So right now, you have phones with 90 hertz refresh speed, 120 hertz refresh speed, 144 hertz refresh speed. So greater the refresh speed, the thing is the images appear smoother. One last thing I want to say is, same if you want to record some image at 480 frames per second or 980 frames per second, even in your Samsung phone, what happens is you cannot shoot it in indoor at all. Because now what happens is every frame is exposed only for 1/488th of a second. And to compensate it, you have to give very high external light. So that's why you can, to take high speed photography, you require very good lighting. So with this said, we have now covered all the basic topics about the exposure settings. We have discussed about aperture, shutter speed, high speed photography, and also about the color balance and also about image sensitivity. So next, let us jump into Unreal Engine and start simulating all these controls in our virtual cameras. So this, we are going to start it from our next session.